Thank you for clicking on the video. I really appreciate it. If you haven't subscribed and liked, please consider doing so. So what I do on this channel is I take old electronic projects from old electronic magazines and I build them. I bring them to life. That's what I do. If that interests you, please continue to watch. And even if it doesn't interest you, maybe hang in there anyway. It might be a lot of fun. I'll try to keep it simple. Again, I always say I'm here to have fun for entertainment. I'm not here to educate. I'm not an expert. I'm not a genius. I just have a lot of fun building this stuff. I received an email from an individual, John Barnes, last week with regards to some of the projects that he had designed and built and published in Everyday Electronics. And it was a new magazine to me. I've never heard of it before. According to Google, it was a UK-based magazine. So John had, like I said, emailed me, and he had mentioned he built 5 of the projects. So there was 5, there were supposed to be 6, but one didn't make it. The 5 projects were all in April of 1983. So that's 42 years ago, right? And like I said, this one's the function generator. And he showed me that he sent me a picture showing me the 5 devices, because he kept them, of course. Why wouldn't you, right? And I decided, well, why not build one of them? I sure could use the function generator. So that's what I'm going to do today. I'm going to build the function generator that John designed back in April of 1983. And the best part about this is I have John's email, and if I have any problems, well, I could just go to him. So that's what I'm going to do today. I'm going to build the function generator from Everyday Electronics. All right, so I'm just showing you the schematic. And if you really want a good description of the schematic, just go to the link for the magazine itself in the description of this video. John had designed everything, and he describes it very well in the article. And maybe he'll even leave a comment, because I think he'll watch this video. And if he does, I'll pin it to the top. So you've got your input, an IC1, and according to the article, it gives us linearity in terms of the frequency variation. And it's a voltage follower that's fed into the XR2206, which is very, very, very popular function generator chip. And we've got our ranges at the top. You've got 5 capacitors there. And the output of the XR2206 gives us a sine, square, and triangle. And what John did is he took the square wave and made a separate output for that. So for TTL logic and chips and stuff like that. And normally we get a sine, triangle, and square out of the XR226, and that's led into the amplifier, the LM318 IC3. And according to the article, TR2 and TR3 are emitter followers, right, for the current gain. And then, unfortunately, this schematic didn't fit on the one page, so I'm just showing you the right-hand side of it. And that's the power supply portion, and of course the output. And it's a 50 ohm output too, which is pretty good. So I'm looking forward to building this. I think I have all the parts. So let me bring you back in. At that point, I'll show you all the parts and the boards, etc. Okay, so pretty straightforward. These are the parts. Pretty common stuff. There is one transistor, TR1, which is the BSX20 NPN. The ECG equivalent to that is 311. I didn't have that transistor, but I looked through all of my other transistors, and I think I've got some pretty close equivalents. So we'll see how that works. That's for the TTL output. Otherwise, yeah, just standard fare. And let's get on with the build. right, so as you can see, the boards are etched as per the previous sped up clips. Let me know if you like that. I'm just experimenting. I'm new to this YouTube, and I'm learning things every day. I'm hoping my production values go up a little bit, but I only have a week to do a project, right? So sometimes that's not enough. But I will let you know that I do spend at least 6 to 8 hours every day building projects. So I do put a lot of time into it. Now, there are a lot of projects that you haven't seen because they don't work. Well, actually, I did post some that didn't work and I got your help, but I probably have about 4 of them, I think. I just can't get going. It's this most bizarre thing. I still haven't figured it out. Anyway, back to this topic. So yeah, everything got etched and the boards turned out really good. Thank you, John Barnes. You're the one that designed these boards. So I just copied them from the magazine, cleaned them up a little bit, made the contrast a little more darker, and printed them out onto the blue transfer paper, right? So I'm really hooked on that stuff. And I wanted to show you that that you can reuse small pieces. So leftovers, you just print out the board on paper, and then you just put the blue toner transfer stuff on top, like a little section of it, put it back in the printer, and away you go. So that's how you can make the most out of your blue toner transfer paper. Anyway, yeah, let me know if that sped up click with the process of making the board, if that interests you, let me know in the comments. Otherwise, I'll just leave it out. Anyway, let's get these things drilled out and I'll get back to you. All right, so we're at the point right now where we want to test the voltages on the chips, right? First of all, the regulators, they're not hot. They're just a tiny bit warm, which is fine. And that means I don't have a short circuit somewhere. And the voltages are plus 12 ground and minus 12. So 24 volts rail to rail. So I'll just check. I've already checked them. The voltages are, there you go, 24 volts, close enough. And that's on one op amp, and the other op amp is the same thing, and the XR2206 also will be working from 24 volts. Anyway, so we're at the point now where I can connect the switches up. So I'll do that next and then put the chips in and see if it works, right? Okay, so you can see that I've got everything connected. I've got all the potentiometers, the selector switches, the power supply, etc. hooked up. It seems to work. There are some small problems. So let me just bring you over to the scope. And you can see I got a triangle wave. And so this is the selector switch for the actual waveforms. So I'm getting a square wave, triangle wave, but I'm not getting a sine wave. The other selector switch is for the ranges, right? Turns of the time base. So that's working fine. Those 4 are working great. And this is the adjust frequency here. You notice that it's almost like there's a dead spot in the middle. Well, I'm reaching the end of the potentiometer. Yeah, there's something wrong with that pot. I think I'm going to have to change that. Okay, so let me get back to the drawing board. I'll fix the things. I'll get the sine wave, or at least I hope I will. And I'll bring it back in. Okay, so it's Thursday morning. I hope to get this out by Friday. Yeah, I fixed it. I fixed all the problems. So as I mentioned in the last clip, that pot had some dead spots on it. So I took it out and replaced it with an old pot, but a good pot. Cleaned it and it works perfectly. So that's the frequency adjust, right? So when you're in a range from that, that's the range switch. Oh, sorry, that's the range switch there. And within that range switch, you can actually adjust the frequency. And this is the selector switch for the sine, triangle, and square wave. So I had a problem where I was getting two triangle waves. Well, it turns out that I had the white and green, sorry, the orange and white wire reversed. So I fixed that. And I also had a problem with this pod too, where it was flaky. It was some sort of connection problem within the potentiometer, so I replaced that. And the pot up here, or sorry, the trim pot, that was not good either. In fact, it was working okay, but then I put some contact cleaner in and I never recovered. So I easily just changed that out. So everything's working great. So let me just show you on the scope. I'll just do a couple quick demonstrations here. So that's triangle wave, that's square wave, triangle, sine, and I can adjust the level. And the range switch is here. And pretty flat. That's the last range. Okay, it's down a little bit, but yeah, pretty good for an XR2206. So what I'll do now is I'll put everything in a case and then I'll bring it back in. All right, as you can see, it is done. I'm really happy how it looks and of course how it works. So yeah, you've got all the knobs. You've got your output. This is TTL output. You know, you got sine, triangle, square, and this is the frequency adjust. And that's the frequency range, and that's the amplitude. Can't really see the label, but it's there. Yeah, the power switch and of course the LED. The knobs look really good because they were old knobs and they were just caked in nicotine. And I tried cleaning them with alcohol. It just didn't do much. And then I figured I'll try this foam cleaner here. And it worked great. It took all the nicotine off. It's fantastic. I'm not getting sponsored. I'm not even making any money on YouTube, by the way. So yeah, anyway, that's the front end. And this is the inside of the function generator. I probably could have shortened these leads a little bit longer, but I had to go from the left to the right, and the LED had to go from the right to the left. And it was just the placement, right? So this project box only has so much room, and I ended up with this configuration. In any event, there's no issues with noise as far as I can tell. Yeah, it's a pretty simple circuit designed by John Barnes, who's probably watching this video. Thank you again, John, for such a great design. I followed your instructions. This pot here, I think I mentioned it earlier, that gives you the maximum peak. So I set the volume control or the amplitude to full, and then I adjust or back this off, and that's the range. So I get, it took me, well, it didn't take long. It took like about 10 minutes. But I've got the range going from 10 hertz, and I can't remember what the maximum range is, but we'll find out. I'll put this on the scope and we'll check that. But I got it down to 10 hertz, which is pretty good. In fact, I could get it even down to lower. I think I had it down to 2.5 at one point. But 10 hertz is a good low range value. Yeah. So, you know, just a typical power supply, plus and minus 15. Design again from John. And yeah, so there's the AC coming in. Goes, well, the live goes to the fuse first, and then from the fuse goes to the switch, comes back, and then goes into the transformer. Where are you? There it is. So that's the AC input. This one is the neutral, so that just goes directly to the neutral of the cord. Gosh darn it, yeah, I mean, looks pretty good. I'm happy with it. And, oh, I'll show you the back. There we go. I'm trying to hold it up with one hand. Yeah, pretty simple. Anyway, so let's put this on the scope and see how it performs. All right, so let's do a few tests on this function generator. So let's just go through the range, the frequency range. So I've got the output of the function generator going to a cheap frequency counter, and I'm just at the very bottom. So I'm on the lowest scale, and this is the lowest frequency. Now I know it's 10 hertz. This frequency counter is just not picking it up. But if I just bump it up a little bit, you'll see it starts to catch on. And away we go. This is the frequency range. And that's, we're on the kilohertz scale too, by the way. So this is now about 280, 250. Again, this frequency counter is horrible. But we're in the hertz, so 250, 300 hertz. Let me just go up to the next range. We'll get a little bit more accuracy. And I'm just going down. Okay, so that's the maximum frequency there. I'll go up to the next range, 21.6 kilohertz. And we're at 113.93 kilohertz. So that's not bad. So usually 100 kilohertz would be the max on this thing. And so that's a range. I know it does 10 hertz, and I know it goes all the way up to, now I know, 113 kilohertz. Not bad for a function generator from 1983. Yes, I know. I've got a function generator up there, the Rego, which isn't working very good, by the way. I know that goes up to the megahertz, but hey, this is great for audio applications. Nothing wrong with this. All right, let's move on to another test. Okay, so let's test the actual function generator on the scope, which you can see, hopefully. So right now I'm at the very, very lowest frequency. And I'm still at 4 volts, I think. 1, 2, 3, yeah, about 4 volts. And this is what I said was 10 hertz. So that was not being picked up. That signal from the function generator was not being picked up by this frequency counter. But it's there, and it's clear. It looks really, really good. I'll just increase the range. As you can see, we're getting higher and higher. That's just with the frequency adjust knob. So let's go to another range. There's the second range, the third range, the fourth range. And when you look at the scale, it's very linear, pretty much. Well, that's not a range. That's 4, 3, 2, 1. So it's pretty consistent. And the sine wave looks really, really good. So I'm going to go down in value. And I'll go to the bottom here. And you can see I'm on the 5 millivolt scale of my scope, and you can see a signal there at least 5 millivolts. So that's pretty good. Bring it back up. And it looks very clean too, by the way, when I'm looking at this signal. I'll crank it up. Oh, go there. Yeah, I'm on the 1 volt scale. All right, so let's I guess I showed you the frequency range. Yeah, I showed you that. And let me show you the other signals. Oh, wrong way. There's a triangle wave. Same thing, I can adjust it. And square wave. It looks half decent. Nothing wrong with that. That's the highest range right there. Looks pretty square to me. There we go. All right, so that's really all there is to say on this thing. It's just a function generator, so I'm not going to get in depth with the testing. I know there was the author had mentioned he was getting 0.5% total harmonic distortion, which wasn't too bad at 1 kilohertz. Yeah, I'm going to leave it at that because I got to get this video out. It's getting late for Friday's release. I think I've got a winner here. So once again, John, thank you for the design. I really appreciate it. Look forward to building some of John's designs. As I mentioned in the beginning, he's got 5 different projects in the year of 1983 magazine, Everyday Electronics. So give it a look. I'll put the link to the April issue, which concerns this function generator, and have a look at that. So yeah, so thanks for watching. I really appreciate it. Check out some of my other videos if you haven't already, and bye for now.